Calculus, Unit 2, Day 16 notes. Our objective, solidify the concept of the derivative being the tangent line and learn to approximate the value of a function using the equation of a tangent line. So we're given a graph that's a quadratic function. The question asks us find g prime of -4 and explain what this value represents in terms of the graph of the function g of x. So first thing I want to do is write g of x in polynomial form, take the derivative, and then we'll substitute in that when x is -4, and we'll find out what that is. Okay, so the first thing I did was write in polynomial form, then I used the power rule to take the derivative, then I substitute -4 in for x, and I get -2. What does that represent? It represents the slope of the tangent line drawn to the graph of g of x at x equals 4. And if we look, that's pretty close, and my slope is down to over 1. So let's keep building on this. So number 2 wants us to find the equation of the tangent line drawn to the graph of g of x at x equals -4. So what do I need? I need the point where they intersect, and I need the slope of the tangent line. Then I can point slope equation, I can get the equation of the line. The point, I know I'm at x equals -4. I can substitute into the original function g of x or into the derivative g prime of x. Both times I'll get -2, because if we look up above, that point is on both the original graph and the tangent line. Next, we find the slope of tangency. Hey, that's when I substituted in -4 for x in the derivative up here in number 1. And now let's use the point slope form of an equation of a line to write this equation. And that's what they're looking for. And then when to sketch a graph, I did that already. On the AP Calc test, if they want an equation of a line, I'd leave it like that. Let me take 2 steps to write it in slope-intercept form. Okay, next use the equation of the tangent line to find the value of y when x equals -3.9, then put it into the original function g of x. So when I do that, tangent line, substitute in, we get -2.2. When I put it into the original function, which is a parabola, I get -2.195. And then this leads into question number 4. What do you notice about the value of these two results from question 3? What does this imply about how the equation of the tangent line might be used? And that's part of what our objective was. So the two results are very close in value to each other. So therefore, the value of a function can be approximated using the equation of the tangent, provided that the x values in question is close to the point of tangency. So our point of tangency was -4, and we substituted -3.9. So that allows us to approximate the value of the function. There you go. All right, for the next one, does the graph have a horizontal tangent? And I kind of drew what I think it might be. And it appears to have a horizontal tangent at x equals 1 because that's where the relative max was. And it says show an algebraic analysis to support your answer. So what I'm going to do is I rewrote the original function. So instead of square root of x, I wrote x to the 1/2. Now I'm going to take the derivative, and I'm going to set it equal to 0, and I'm going to solve for that value of x. And that should come up to be x equals 1. Let's see if it does. So set the derivative equal, find the derivative, set the derivative equal to 0, solve for x, do a little algebra right here, we get x equals 1. So since the derivative is 0 when x equals 1, then g of x has the horizontal tangent at x equals 1. That's what I just proved. 6 and 7 asks, when is the derivative positive? When is it negative? It actually starts with negative. So here's my original function. So this is going to occur, the derivative is going to be negative when the original function is decreasing. Hey, it looks like it's decreasing from +1 to infinity. And then when is the derivative going to be greater than 0? That looks like it's going to be when it's increasing, and that looks like that occurs just from 0 to 1, not including the 1. So let's write those down. And there we go. Derivative is negative when the original function is decreasing. That happens 1 to +infinity. And the derivative is positive when g of x is increasing, and that happens 0 to 1. Let's do 8 and 9, and then we'll go to the next video. Okay, when do I have a tangent line that has a slope equal to 2? So that's saying when's the derivative equal to 2? This is what we found for the derivative, and now I just set those equal to each other, and then I can solve. So let's do that. So 1 over square root of x equals 3. Set that up as a proportion. So means extreme cross product property. Oops, that's 3 times square root of x equals 1. Divide both sides by 3. So we divide both sides by 3, we get square root of x equals 1/3. Let's square both sides, and x equals 1/9. So that is a spot on the graph where the slope of the tangent line is equal to 2. Okay, next one, let's find the equation of the tangent line drawn to the graph of g of x when x equals 4. So when I know x is 4, I can substitute into either g of x or uh, into the equation for my derivative. So we find in both cases it's going to be 4 comma 2. Okay, so now let's go and find the slope of the tangent line. So that goes into the derivative. So when we get our point of tangency, and I was saying we got to wait till we get the equation of the tangent line till we substitute that back in. If we have the equation of the tangent line, then we're going to get the same y coordinate when I substitute in x. So I got this by substituting into my original g of x, and now on my slope of tangency, it's 1 over square root of x, so 1 over square root of 4 minus 1, and that's 1/2 minus 1, and that is going to be negative 1/2. So my slope of the tangent line is negative 1/2. Now, let's substitute that into point slope form of equation of a line. So it's going to be y minus 2 equals slope negative 1/2 times x minus x1. So there is my equation of the tangent line. Now if I put 4 into that, I will get 2. Let's try that. 4 minus 4 is 0. Y minus 2 equals 0. Y equals 2. Okay. And I could rewrite this in point slope form. Excuse me, I used point slope form. I can rewrite it in slope intercept form. Y minus 2 equals negative 1/2 x plus 2, and then y equals negative 1/2 x plus 4. So those both represent the equation of the tangent line. If you had to take the AP test, this you just leave it in point slope form. We don't need to go to slope intercept form. All right, this will be part 1, and we'll keep going in a second on part